All right. So using our factoring by grouping, this is what we went through yesterday. That's when we go, ew, I really don't want to deal with this as it is. I would really rather deal with it in smaller pieces. So we break it into smaller pieces. And be like, let's play with the first two pieces and the second two pieces. So on these first two, what do they have in common? 2 and b squared. So my leftover parts, what's left over when I take out 2b squared is just b and minus 2. Then we're going to do the same thing over here. On this green pair, what do they have in common? What's the GCF of these two, 3b and 6?
On ours is just b.
Ooh, love it when I've done things that are weird. Let me see. Oh, it is just a b and a minus 2. Okay, cool. We rock with that. B and minus 2. Still same vibe. What do they have in common?
1.
Just a 1. So even if there's not anything we can really pull out as a GCF, we're still going to write it there. Because now we're left with b minus 2. So what we're going to do is we're going to pull out that b minus 2 as a new GCF, and we're going to put it in the front. B minus 2. And our leftover pieces are 2b squared plus 1. And that is our factored form. Okay, so that's exactly what we did yesterday. Today we're going to take this and kick it up a notch by then solving. So we're going to factor by grouping and then use that to find solutions, roots, zeros, x-intercepts, whatever we want to call it. Okay, so there's 2 more questions on the page, and that is not one of them. Where the heck is... Oh, yeah, it is. Never mind. They're good. Okay. So we're asked to solve this. So now it has an equal sign. It's not an expression, it's an equation. And if it was like a quadratic, we would factor it, x in box, and set each factor equal to 0. And that's exactly what we're going to do here. So we're going to say, again, ew, I really don't want to deal with it when it has 4 pieces. So we are going to break it into pieces, just like we did on the last one. We're going to divide it up into pairs. And look at each piece individually. What is shared between 4x cubed and 12x squared? 4 and x squared. What we have left over is an x plus what? Three. So we're factoring a GCF out of each of the pieces. What is shared between minus 9x and minus 27? Mm-hmm, 9. But they're both negative, so I'm actually going to take out minus 9. And if I divide negative 9x divided by negative 9, we get positive x. And negative 27 divided by negative 9 is a positive 3. So then we're going to write this into our factored form. We have 4x squared minus 9 and x plus 3. Questions on that part? That's the first factoring bit. Because now what we're going to do to get to our solutions, to get to our x equals, we're going to set each of our chunks equal to 0 and solve them. So here's one piece, x plus 3 equals 0. And we're going to have our 4x squared minus 9 equals 0. Well, this purple one, that one's a little bit easier. What do we do here to solve for x? Subtract 3. And we're going to get that x equals negative 3 because we subtracted 3 on both sides. On this left-hand one, we have an x squared still. So what we're going to need to do here is we're going to need to factor again. Or if we can't factor, a quadratic formula, but we're not going to usually be that mean. And this is actually a difference of squares. This is a difference of perfect squares pattern, because 4 is a perfect square, x squared is a perfect square, and 9 is a perfect square. So what squared gives me 4x squared? What's our first term? 2 and x. What squared gives us 9? 3. 1 gets a plus, 1 gets a minus. This is a difference of squares, so that comes back repeatedly. And then we need to set each of these equal to 0 to get these solutions. So we're going to do 2x plus 3 equals 0. And we're going to do 2x minus 3 equals 0. So on this left-hand one over here, we're going to subtract 3 first to get 2x equals negative 3. And then we're going to divide by 2 to get x by itself, and we get the x equals negative 3 halves. And we can leave it as a fraction. That's totally fine. We can leave it as an improper fraction. If you like decimals better, that's totally fine. If you're going to do negative 1.5 or negative 1.5, I don't care how you word it. It's the very same vibe over here, where we have adding 3 first here. 2x equals positive 3. Divide both sides by 2, and we get x equals 3 halves. So our solutions to this polynomial, our answers, are negative 3 halves, positive 3 halves, and negative 3. So other pieces will make little shows again and pop up so that we have to deal with them again. Questions on this first one where we've done all the solving steps? Okay, because that's what the next one is too. Same vibe. And this is the last one. Just making sure they match. They do. So this is where we're going to break it up into our pairs. Whenever we're factoring by grouping, you bust it up into its component parts. And then we zoom in and look at each piece individually. What do x cubed and 4x squared have in common? X squared. And our leftover piece is an x plus 4. What do negative 25x and negative 100 have in common? Negative 25. So sometimes we'll get big numbers, and that's okay. And if I divide negative 25 out of both of those, we have x. And negative 100 divided by negative 25 is a positive 4. So we're going to pull that x plus 4 like it is a GCF. X plus 4. And what's left over gets its own set where we have our x squared minus 25. And we have a very similar thing. I still have an x squared, so we're going to see if we can factor that. We're still looking for those solutions, but I want to get it all the way into factored form. And this piece, x squared is a perfect squared, and 25 is a perfect square. So this is a difference of squares. So we can write this in its special pattern where we have this first piece is staying here. Our two sets of parentheses. X squared is made up of x's. 25 is made by 5 squared. 1 gets a plus, 1 gets a minus. So that difference of squared pattern is going to be super duper helpful for you to know. If you don't, you can absolutely still X and box it. It's just going to take way longer than remembering that pattern. And we are almost done with this because all we need to do is figure out our solutions here, our roots, our zeros, our intercepts. So for this first piece, what's our solution? What does x equal when this is 0? Negative 4. On this next piece, what does x equal as a 0? X equals negative 5. And on this one, positive 5. So our solutions, our roots, our zeros, our x-intercepts on this one are negative 4, negative 5, and positive 5. So they're not super complicated. It's not adding a ton of new pieces. It's just a little awkward, and we have to remember, especially difference of squares. That'll show up a lot of times in solving by factoring. A lot of times. Okay? So that's actually it for notes for the week. There are, on the worksheet that I gave you guys yesterday, it's called number 6. It says halfway down. There's 2 factoring by grouping problems there. So I want you to go ahead and try and do those. There's a couple of review questions on there. Tomorrow we will be working on the review. The review is on Alex. So if you finish this worksheet and you want to start working on the review, it's up on Alex. Which, as a reminder, to get to Alex, you go to either Canvas or Clever. To McGraw-Hill. And then you go to Alex. And it should pop up right when you log in. If not, let me know and I can help you find it. But that's what we're going to work on tomorrow. The review is only on Alex. I'm not doing a paper review. That's just too many papers in 1 week. And then we're doing a quiz on Friday. Friday's a quiz is Friday. Okay? So pretty chill. Pretty chill. Let me know if you guys have questions on stuff. But that's it for today.